Ladies and gentlemen, please welcome our next speaker, Michael Kaufmann, presenting the topic, From Application Security to Developer Security, Shift Left with GitHub Advanced Security.
If I talk to my clients about security, then everybody is aware that security must be a high priority, right? And that's really obvious. If you look at the numbers from the last years, these are the official losses reported to the IC3. IC3 is the department of the FBI. So these are the official numbers in the US. And you can see in the last 2 years, the losses basically doubled and are now at $12.5 billion a year. And this is just the official numbers. If you imagine what else is there that is not reported, I mean, these are huge numbers. And that's why every customer, also in a lot of studies and everything, security is always a high priority. But if I work with developer teams and DevOps teams that maintain and run applications, looking at how well integrated are security practices there, I don't see a lot of things, right? So the adoption from security practices that I would say are state of the art are still very low in the field. And the question is, why is that? And I have one comparison for you, and I want to compare it with two groundbreaking inventions in medicine in the 19th century. And they're both on this picture that you hopefully see every moment. Are the two groundbreaking inventions, and that is anesthesia and antiseptics. So anesthesia was first discovered in 1846 and with diethyl ether, and it was used worldwide within 1 year, right? And a few years later, it was ubiquitous. It was like everybody used it. If you compare this with antiseptics, this was very divisive, and 20 years later, it was still only half-hearted implemented in most countries around the world, but it's now also considered a foundation of modern medicine. So what made these two inventions so different? What made the adoption so different, right? And it's also in the picture. You cannot see the picture now. I hope this will change. No? If not, I will just skip it. I hope there are not more pictures. Okay, so there's a picture. You see it here in the background. So that man in the middle, that is a surgeon. And then on the right side, you see this machine. This is antiseptics. So this started with a machine that created a lot of vapor. And on the other side, you have anesthesia, right? With diethyl ether, where your patient will just be rendered unconscious. And if you imagine this from the standpoint of the surgeon, right? For a surgeon, if your patient is screaming and moves, so that's not a good working environment, right? So anesthesia really makes your working environment much better. And antiseptics, it was this machine, you could not see well, so this made your working environment worse. And who decides or who has a big influence on the adoption of new invention? That's the surgeon, that's the main actor here. So if I compare this with DevOps and security, right? Anesthesia is DevOps. So we make the world of developers better. We help developers to be able to deploy on Friday and still go home with a good feeling. We help them through automation, automated tests. That makes the life of an engineer much better. But security is like antiseptics. It makes noise, it's not integrated in the process, we have a separate company reviewing our code, then it's already deployed to production and we get a big Excel with a lot of findings. Some of them are related to the architecture, it's really hard to change them. So it's kind of a pain, and that's why developers sometimes refuse it, right? So they don't like it and they do it because they have to, but it's not ideal. And I think that's the reason, right, why security is not yet as adopted as other DevOps practices. So, okay. Short introduction, who am I? Michael Kaufmann, I'm the managing director of Xivia in Germany. We're a consulting company, we help our customers with DevOps, with implementing new engineering techniques, with shifting left on their way to the cloud. I'm in industry for more than 20 years, doing DevOps or application lifecycle management, like we called it in the early days, for more than 15 years, or nearly 15 years. Wrote some books about it, and I'm a regular speaker on some conferences. I'm a Microsoft MVP, Microsoft RD, Yeah, happy to connect. I will be later at the Ask Me Anything corner, so step by and happy to connect. This image is working, yes. I just discussed it here before the talk. If we talk about security and incidents, there's still one big problem in our industry, and there's a big misconception, and that's from the movies, right? If you look at hackers in the movies, you always see a guy, normally with a hoodie, and he's typing very fast in a terminal with green things, and then you hear people saying things like, "Oh, I hacked the third firewall, and I cannot get here. They keep changing the IP address." And you're like, "What the fuck?" That's not how hacking works, right? If you ever debugged or try to find a bug in a software, you're probably more likely to look like the second guy, and you read a lot, you do open security information, research, and it's not hacking in a terminal. It just has nothing to do with it. But that's why a lot of people, they don't dare to speak about security, because since I cannot hack, it's a skill I don't have, I don't want to talk about it. But that's not the case, right? Like everywhere in engineering, we have our special skills in some things and some skills we don't have, but we could acquire them, right? So if you want to learn to hack a thing, you can learn that skill. It's not so difficult. But this misconception, how people get hacked, lead also to a lot of misconception how the entire thing works. And I really like that here, how people think they get hacked, right? So by the hacker that is sitting there and typing very fast, and how they really get hacked. This, for example, here, this games and Facebook, where you expose personal information that then can be used to, for example, reset your passwords. And to set the scene for the talk, I want to talk about a real incident. And the problem with incidents is that they're normally so complex that they're really hard to understand. Right? If you talk solar, wind, or something, so we don't even know yet where it started. Then we have some information, but it's very cloudy, and then it gets really complicated. So I want to take one which is very simple, but really shows well how an attack can be orchestrated. And what I want to talk about is the event stream incident. And event stream was a very popular NPM package. The incident happened in 2018, it's some years ago, but I think it really shows the story very well. So event stream was a very popular package, millions of downloads, and like every open source package, at the beginning the maintainer is really happy, right? Wow, my package has a lot of success. And at some point they realize, fuck, this is a lot of work. I don't get paid for it. I get hundreds of issues every day. Everybody wants something from me, and I really could need help. And one guy offered help, and that was a user called Right9Control. And he helped triaging issues, he helped created some pull requests, and it was over a month, and he gained the trust of the maintainer. So event stream was used in many, many packages and many, many applications, and one of these applications was called Copay. Copay was an open source wallet for cryptocurrency. And Copay was attacked so many times in many different ways. It's now called BitPay. It's still out there, but it's called differently. So Copay was a user of event stream. Right9Control gained the trust of the maintainer, and at some point was given write access to the event stream repository. So what did Right9Control do? He would introduce a new dependency to a package called FlatMapStream. And the package was a new one. It has just one commit in GitHub. It's just one version on NPM. And the community was asking questions, right? The community of EngineStream, why do we need this package? Can't we write this code on our own? It's not very complicated. And Right9Control directly reacted. He removed the package and updated the version to 4.0, so to a new major version. So if you as a client from EventStream would directly update your dependencies to the newest major version, you wouldn't have been impacted by the FlatMapStream malicious code that was then introduced, right? But of course, people don't upgrade right away to the latest version. And that's what happened. So the FlatMapStream package got a new version, and the way versioning works in NPM, you would always get the newer version if you build it. And the new version had malicious code. And the malicious code would directly check, is the client I'm running in Copay? If yes, it would decide on some things. Then it will look how many bitcoins are in the wallet. If it's more than 100 bitcoins, it would harvest all the bitcoins, upload it to a control server together with the private keys, and that's it, right? You can imagine 100 bitcoins is a lot of money, so it's worth investing a few months social engineering, like Right9Control did, and you can make a lot of money with it. And I really like this incident because it really shows how things can happen in a time frame, right? It starts with social engineering attack. Then you attack the supply chain. So you do not directly ingest malicious code into the software itself. You just ingest one new dependency. And then at some point, you add the dependency. And then people do not talk about it because you already upgraded it. You removed the dependency. But of course, your dependents, they still get the malicious code. And that really shows how you have to think about security from a developer perspective, right? There are a lot of attack vectors. The developer can be attacked through social engineering. The development environment can be hacked. The source code, of course, if you can inject something there, one line of code basically can remove a lot of security. You can, for example, remove authentication requirements for parts of your website. The build system can be attacked, like in the SolarWind incident. The package itself can be tampered, deployment, consumer, and so on. But the biggest part or the biggest risk are the dependencies. And if you look at today's applications, every dependency you introduce has its dependencies on its own. And these have dependencies, and these have dependencies. So it's a big tree of dependencies. It's thousands of dependencies with just one package. What you see here is a visualization of Gatsby. So if you install Gatsby, this is the tree of dependencies you get. And I play this visualization in 10 times faster than it normally would be, because it's so many. It's 2,000 and something. And like every dependency in Gatsby here has the same attack vectors, right? So you cannot just attack the application you want. One of these dependencies in this tree, you can attack. It looks strange. Okay. You can detect the developer, you can attack the development environment, the package, and so on. Yeah. And this is also something you have to take in mind, that these are attack vectors, and every dependency you have brings other dependencies, and they are potential attack vectors for your application. So what we're trying to do is shift left security, because fixing security bugs has different costs at different stages. So I know you can really argue about these numbers, and I have the source here, but I've seen them in dollars and euros. I think the absolute number here doesn't matter. But if you fix a security bug during development, it basically costs you nearly nothing, right? You fix it and that's it. If you fix it after deployment to a test environment, or while already manual tests are running on it or something, it costs you a lot more. If it's in production, it can lead to millions and that your company gets bankrupt, right? So this costs in mind. The more you shift left, the cheaper is security for you. And a lot of times I have discussions with customers about pricing costs for security tools. And it's always like, okay, have you considered what a breach will cost you? And then normally the discussions are over. So security costs money if you want to do it right in a productive way, but it will also save you a lot of money. Give me one moment. So let's start with developer security. So how can you attack developers? Right? We've already seen the social engineering, but there are more things that you can do to attack a developers. And I made up this one quote here. I think a developer is just a normal employee that is normally local admin, runs unsecured web servers, and has access to a ton of other systems. And a lot of people come up, oh, I've never thought about this way. Right? If I talk to administrators, they always know that they're a target of attacks, right? And they will, for them it's natural. If they do administrative tasks, they log in with their admin account and then they log out. They don't work all day long as domain admin on their laptop and read emails. For a lot of developers, that's not the case. Any developers here? A few. Leave the hand up if you work as local admin. Some don't dare. Yeah, see, yeah. On security conferences, it's normally, no, we would not do this. If I see the same person on developer conference, like all people have their hands up, they're like, yeah, I also work as local admin. So it's getting less, but it's still a lot of developers are local admin. And they normally work all day long on the machine where they have their Outlook, where they open their email, and they're local admin. And that's just, they don't think that they get attacked, because why would I be attacked? I'm a developer. But they are, right? So, and I will show you right away what you can do. social engineering and phishing. Phishing is a really big topic, and I really want to stress this because mostly also developers, they hate phishing simulations. They say, I'm good. I know what phishing mails look like, right? So I know that. And I worked for another company. They did phishing simulations. And I started there with a big team of nearly 30 people. And they hated it. I know what phishing is. And in the course of 2 years, like nearly everybody in this team would at least once accidentally click on a normally simulation mail. You can see here two phishing mails. One is a real deal, and one is a simulation from the company. And the number of phishing mails reported really went up. Right? If you do simulations, the reporting will go up. And what especially engineers often forget when they think about phishing, that in theory, if I give you two mails and I ask you, is this phishing or not? You can tell that it's phishing. But if you're in a moment that you're primed, that you're expecting an email, that you have some urgency, in that case, you lower, you're not looking for this signs you have. You're not looking for the URLs, right? So if you just check your bank account at the end of the month and your salary is not yet there, and you get an email from HR that says, hey, we have a problem with your salary, then you're just expecting this email. In this moment, you will not check. You maybe just click on it and then you think, oh shit, I did not check it. Or in the morning, you log in, you have a problem logging in, and now you get an email that says, we have a problem logging you in, and you might just expect it. I was on a call with a colleague from another unit, and he was like, oh, I'll send you the file. And I got this SharePoint something file, and I clicked on it because I was just, what tool? And then, of course, I did not enter my credentials. I reported the phishing, but it was a real phishing that I received. But the moment you are primed, and the moment it is urgent, you lower your defense, I would say, and it happens that people click on it. So I really advise you, do phishing simulations. People will hate it, but people will get better. They will create awareness and they will report more and click on less. But besides phishing, there are other things how you can attack developers. There's something called typo squatting, or a form of it is namespace shadowing. So if you're a developer and you type on your console npm install cross-env or npm install cross-env. So the second one is the real deal. This is what you want, the package cross-env that will help you with environment variables. But the first one will steal all your environment variables and upload them to a control server. Or the same with namespace shadowing, where you would just forget to enter a namespace, right? So the normal package lives in the namespace Azure and the other one has it not. And of course, NPM here fights to get out these malicious packages, but sometimes you have 400 packages a day that get uploaded. So this is like a really uphill battle. So if you don't have measures in place to find these dependencies, that can be a real problem. And it's not just attacking developers to install time, where you upload your, for example, all your environment variables or check for secrets around. Some of these packages will just add the other dependency as a sub-dependency, will just forward all the calls to the dependency and then lie there in a package and wait until they're at the client, right? So they can live there, and if you don't have a package or something that scans the dependency and says, hey, you have a problem here, you might not even know it. So you added a dependency to cross-env or something, it will just do what it's supposed to do, and at some point it can act malicious when it's already installed in a user application. I have some developer colleagues and say, hey, send me some examples for secrets you are using in your day-to-day life. And like everybody sent me something. So if you're not having secrets somewhere as a developer, you're either not you're just working with local applications that don't have even a database, or you don't do test automation. So the moment you do test automation, you have test accounts and you have secrets somewhere that you have to enter. And if you work against an API, you need tokens. So if you look around at a developer machine, there are a ton of secrets that you can steal, right? Hopefully it's just on the machine and it's not in the code, but it's there. So attacking a developer will give you a lot of secrets that you can use then to attack other things. And that's why we really have to make engineers and developers aware that they're a target of attacks. So what can you do with the credentials of a developer? You can do spear phishing, right? So if you have the real credentials of a developer and can send emails in his name, if it will come from an engineer, people are much more likely to open attachments, to click on it, because this is a trusted person, right? So, and you might send something to an admin, he thinks, oh, it comes from a developer, I can open it. You can log on to machines. A lot of developers have access to test machines. a lot of test machines still today are in the same domain as a production domain. So you log on, also an administrator logs on. If it's not the newest patched machine, you can use a tool like Mimikatz to read passwords even from other persons. And then you have the admin password. You can inject code. You can execute code on test machines, on build scripts. You can modify the pipelines. You have access to test environments and sometimes even prod. Right? Then you have access to prod, then basically game over, and as an attacker, you have achieved your goal. This is a screenshot of Mimikatz. Anybody knows Mimikatz? Yeah, some people do. I really advise you to try it out. And it's not just, if you have the newest patched Windows version, it will not show you passwords from other Windows accounts that are logged in on your machine. But you will still get a lot of clear text tokens from GitHub, from GitLab, from Office, a lot of clear text information. And on not patched machines that have not, that are maybe a few years old, you can get really in clear text passwords from all other users that are logged into the machine. Right? So if you have a test machine, which is not the latest version from Microsoft patched, and an administrator is logged in, you can log in on the same machine, and then you have the password of the domain admin. And I think this is the thing that also developers have to learn about security, that attackers do not think in lists, they think in trees. And the way that you can come from one account or from credentials that you find somewhere, there's always a way to get somewhere, right? So for example, you find test accounts documented in a text file that are used for automated tests. They can be used to log into a development machine where also here the developer MKA has access. So you can Mimikatz, get his credentials, log into a test machine where he's on, and on this test machine you have domain admin Lisa, and then you have Lisa's credentials and you can log into production. Right? That's why you should always separate domains for test and production and not have the same domains accounts, because this will then pollute your production. And there are a lot of tools that help you with this. For example, Bloodhound. So Bloodhound, you can just run it in your AD environment and it will just say yes to everything and then create a big graph how you can navigate from one node. So you will get all the computers, all the logged in, all the accounts, who is logged where. And this way you can like create your tree, how you can navigate to a certain system. And there are a lot of other tools that you can use to get the first step, right? One is finding credentials, one is social security, one is phishing. There's Responder that you can run in your network that will just respond with yes to all login requests. And if you have weak passwords, you can just brute force them and get the password out of it. You have devices like Pineapple where machines log in. So there are a lot of entry levels. But the thing is, once you have the credentials, what happens then? So what to do, right? So you should do security awareness trainings with your developers. There are some games that you can include in your sprints that you can have execute them or play them at the end of the sprint. And of course, phishing simulations, we talked about that. That's like a must-do for me. But I think the best thing you can do are capture the flag events or red team, blue team simulations. And they still have a, I wouldn't say a bad reputation, but they have a reputation that they're only for the big companies, right? Oh, we are not Microsoft, we cannot do red team, blue team exercises. And I think that's not true. I think if you have developers, and you just think about it, what would the developer more like to do? Filling out a spreadsheet with risk factors for their application, or doing a hackathon where they try to attack their own application? And I think the answer is really easy, right? You have some developers, you say, hey, attack your own application. And then you have another team that say, hey, protect it. Try to find out that you get attacked. And they will have a lot of fun. And you can add some consultants and some red team support at the beginning if you need it. But normally, if you're a developer, you know your system, you know how to hack it, right? So if you really think about it, they will find a way, even without help. Give it a little bit help and it's more fun. Of course, you need a lot of rules around it, right? So you cannot put real information on the internet. You don't want, or unsecured on the internet. You don't want to put your production system down. So you really need rules here that allow you or that tell you what to do and what not to do in the simulation. But these kind of hackathons, they're a lot of fun, and they will create a lot of awareness, and they will really teach the engineers how to think as attackers. So this is really like, give a man a fish or teach a man how to fish, right? So this really teaches developers to think like attackers and brings a lot of awareness and security into their day-to-day life. One topic I really want to highlight also are virtual development environments, because virtual development environments, this is for me the perfect anesthesia, right? So this is something, it brings so much security because it will remove this, I work as a local admin, from one day to the other. You don't need to be a local admin if you have virtual development environments. And it makes you not just much more secure, but also much more productive. So GitHub itself, they built GitHub on code spaces, and they created code spaces because GitHub is a big monolith, right? And it's a big mono repo, and just forking this repo was a very long process. Installing, this was all Mac based, installing all the tools on Mac, it was like hours to days until a new engineer could start writing the first line of code for GitHub. Now they have code spaces. They have pre-built images with a sparse checkout, and people will just download the image and they can work in seconds basically, yeah, or maybe minutes, but really fast. So this really is a production booster. You don't have to care about local tools installed. You always have the right configuration with the right version in your virtual environments. If you're more a Windows guy, there's also DevBox, which is the Microsoft product, which is more Visual Studio focused. And there are other tools. I'm not caring about the tool itself, but having project-specific or product-specific virtual development environments makes developers much more productive. If they have a config as code that developers can share their tooling with a team, at least most of the tooling, and the most important one, it makes the entire team more productive. And it makes you more secure because developers are not local admins anymore. So, developer security. Let's shift over to code security. That's what people always think about, right? If we talk about DevSecOps or shifting left security, that's the code. How do we get the code secure? So most vulnerabilities, or the average availability, is 4 years in code until it gets detected. And Log4j was around in the code for 7 years until it got detected and used. And that's the reason why you should always scan your code, even if you don't touch it at some point with new queries. Because when Log4j was found, it was only half an hour later, there was a CodeQL query on GitHub that could help you find it. And I think a few hours later, there was also a variant analysis that would check your code if you did the same mistake than Log4j did. So if you're also vulnerable to this XML injection in that case. And there are a lot of other code scanning tools out there, right? So CodeQL is just one of them. I just want to highlight this a little bit because it's the native GitHub tooling here. It was an acquisition. It was called SEM, and GitHub acquired it some years ago. And it's based from a company that was founded in Oxford. And it was like 30 people that worked there many years on that. So this is really not something, this is something serious, right? And I think the real power of CodeQL is that it combines the good engine of CodeQL with the open source community, right? And if you compare what CodeQL can find CVEs compared to other tools, and of course every vendor will show you other graphs where they are in the front and the others not. I'm not saying that GitHub is so much better than the other ones, right? You probably find other things. But I think at the end it's not what you find. Here in this case, you could see that they find 125 CVEs and Miracode found a lot less. This will probably completely change in other things. But I think it's like with antivirus, right? So antivirus, you probably need to install all if you want 100%, but any of them will find 90-something%, right? And this is the same. So my thing why I favor GitHub is the way it integrates the tooling into the development process. Yeah. So the engine, it's amongst the top, right? So it's one of the top, so you can use it. You can also integrate other tooling, but the good thing is how it brings the code analysis into your developer process. And the real power comes here from the combination with the open source queries. So all CodeQL queries are open source. GitHub has their own security researcher team writing these queries, but there's a big open source community around it, and also a lot of independent bounty hunters that they write their own queries. So, and this ecosystem is really fast in creating new queries if there are new vulnerabilities found in the market. But CodeQL is just one engine, so it's the native engine from GitHub Advanced Security that you can use and integrate the results into your pull request, into GitHub, and they're all in the security hub. But it's an open standard. So GitHub always tries to be a platform. They always try to partner and provide everything as an API and open themselves for all partners. So if you go into GitHub and you click on new workflow and you pick security, you will find a ton of other tools that you can integrate. There's Veracode, there's Sneak, there's like every security tool that creates Sarif, and Sarif is an open standard for code analysis results. So every tool, SonarQube, can be integrated the same way you can integrate CodeQL in this case, right? And that's really cool. And you can not only use code scanning tools, you can also use infrastructure scanning tools and integrate them the same way, because you're probably in your repository there's also infrastructure as code. There might be Terraform, there might be Bicep, there might be Kubernetes, there might be Docker, and all of these tools can also be analyzed, right? So for example, you can use Anchor or Claire if you want open source tools. You can use white source, Aqua, or whatever tool to do container security. And they will integrate the same way into GitHub Advanced Security like the native engine from GitHub does. And not only container, other infrastructure. I've seen the talk before. The question was, hey, how do I detect a public S3 bucket? And there's a cool open source tool. It's free. It's called Checkoff. It comes with around 1,000 out-of-the-box rules for Azure, for AWS, and one of them is finding public S3 buckets. You can see here on the right side. And I think now the default is Sarif. So the first, I think it was a pull request from me, I'm not mistaken. They supported Sarif, but it was not the default. And you could just upload then the Sarif file to GitHub, and it will show up the same way it does in your pull request. So if you create a new S3 bucket in Terraform and it's public, you will get a warning and you can merge your pull request. So it's a really great integration. So I have one very small demo because we still have something to cover. And that is just the pull request integration of CodeQL, right? So this is a pull request where I added one line. Let's go here to files changed. Yeah, internet is working. And you can see here, right? This is the line I added. It's eval this code, and we get a warning that says, "Oop, code injection, this code execute depends on user provided value." And as a developer, I was like, really? Why? And you can click here on show path. And you can see how CodeQL works. So you always have a source and you have a sink. Source is where the data comes from, user input file, something. And the sink is something that happens. Here, for example, the execution. And you can see the source here is window location search. As a developer, yep, that's something the user can enter. And then you can see how the data flows through your application. So in this case, it's not a lot. And here is the sink, and here it gets executed. And you can see on the way how your data travels through your application that it's not sanitized and that there's no check for special characters. So you might add here code that gets then executed. But GitHub will not just show you the way it travels through. You can also see the query if you open the alert. You can learn a lot about the event, but the best thing is you have now autofix. And here GitHub leveraged the power of CodeQL combined with Copilot. So Copilot said, oh, yep, this is bad code. Let me think how to fix it. And it writes a lot, and you get a warning. This is still beta, and be careful and look at it. But it will give you here the fix for the problem, and you can click commit fix, and it will directly fix this issue for you. Right? So anytime you have something in a pull request, Copilot is there and tries to help you auto fix your security issues. So this is Security Hub. Here you can find all code scanning alerts. I just open one. And I just wanted to show you here how you can see, right, there's a lot of documentation. The queries are open source. You can look at them. You get a lot of recommendations. So it's a really good documentation compared to other systems, in my opinion. that developers can work with, right? So developers know why this is the case, because they know how data travels through the application. They can see where the data was assigned to and how it is traveled and why it is an issue. And they can read here a lot of information how to mitigate the issue. So that's really good. Yeah, I think that's enough for the demo. Wrong side. So of course, there's a lot to talk just about CalQL, how you can configure it, how you can write your custom queries. But I would move on rather to the other topics. We still have 2 topics to cover in only a few minutes. Secret scanning. So if you look at the leaked secrets in public repositories, you can see that the numbers goes up and up and up and up. And still, if you continue there in your data, it's still growing. And that of all the security features I show you today, they're GitHub Advanced Security. You have to pay a lot of money if you're an enterprise, and they're free for open source. So for all your public repos, you can just enable it. And still, there are a lot of secrets in there. And if you look at incidents, I think in 95% of all incidents, at some way in the attack chain, there is a secret leak, right? It might be on a developer machine, it might be on SharePoint, it might be on a file share, but at some point in the attack, there's a secret leak because a secret is somewhere. And you should automate that, right? There are a lot of tools. If you don't have GitHub Advanced Security, there's Kitty Leaks, Spectral Ops, Git Secrets, Whisperer, a lot of tools that can help you. If you still have file shares somewhere in your enterprise, you might use Bash PowerShell and some regex to automate something of that, or use Dumpster. Dumpster is a tool for that. But GitHub Advanced Security has at least a good solution for your code. And what they do is they partner with providers. They have now, I think, over 80 providers, right? Azure, AWS, Google, HashiCorp, all of them. And a lot have changed how these companies treat secret. So in the past, it was always just a long string with some characters. And you see now more and more prefixes. And often it's just prefix and a control number at the end. Of course, you don't know that, but they can calculate it. And GitHub will work with a partner, because having just a string is security by obscurity, right? It's just you have a key, and the attackers, they have time. Time is the one thing that is normally not the issue. And they can provide all doors, try all doors. But for an engine to find something, it's much harder if it's just a string. This way, GitHub can determine right away, and the number of false positives, they have really dropped. It's really low. In public repos, it's that GitHub will directly send the secrets to the provider. So they have to implement an API endpoint. So they will send it there. And then it's up to the provider to revoke the secret or do whatever they want. For private repos, not. For private repos, the default is they will not send it out. You will get an alert. It's up to you to revoke it. It's up to you to decide what you want to do with it. But you can opt in and say, yes, please send all my secrets to the provider, whatever it is, for verification, or you can manually send individual secrets there. So that's a really good thing, to have a very confidence about secrets, that they're real secrets. GitHub Advanced Security also allows for custom patterns. So there are patterns, for example, if you have Spring Boot or Oracle databases, connection strings, you can also search by having real complex regular expressions for old passwords, or more like connection strings and with prefix and postfix of the secret. So you can also customize this very well to your on-prem environments if you have them. Supply chain security. I think it's the most important part, and then I can talk about hours for that. But it's also a little bit a boring part, because it's very much into the details. And I think the important part is you need it, right? So there's no way around it. And in GitHub, you have the dependency graph. And on top of this dependency graph, you have Dependabot that automates the update process. And it can automate update of security fixes, but it can also update like all updates. So normal, major version updates, minor version updates. You can automate this a ton here. There are other tools. You can also use Anchor. You can use Dependency Track. A lot of these tools work the same way. And so in GitHub, you have three features basically. You have the dependency graph, which is the underlying thing that constructs how your dependency tree is built. And then you have Dependabot that goes through it and looks for vulnerabilities in the tree and will alert you. And you can configure if you want this alert daily, right away, once weekly digest. You can really configure this. And then in the update, you could click on give me a fix, and Dependabot would create a pull request that you can then merge, and it will be updated to a non-vulnerable version. But if you enable security updates, GitHub will regularly check and will automatically create pull requests for you. The next step is then version updates. You need a config file for this, and you have a ton of options here. You can exclude versions, exclude packages, exclude major versions, and this will also give you pull requests for normal updates. And you can group them together so that for yarn updates, you will get only one pull request that will update all your dependencies in one go. And yeah, if you have the pull request, you don't have to worry about it, right? You don't have to update it yourself if the underlying file changes. So Dependabot will take care of this, and you will communicate with Dependabot through comments in the pull request, right? So you say at Dependabot merge, give a comment, and Dependabot says yes, I merge it, and will merge it. If there's an underlying change of the file, Dependabot will automatically update the source branch for you, and you still can merge it. So it's a really easy process and really reduces the time that developers take to update their dependencies. There's a quite new feature, which you can export a software bill of materials from the dependency graph. Right? This is just the state of quo of all your dependencies in a file, and you can sign it. So this way you can attach your SBOM, your software bill of material, to your package. You can also sign your package, and this is a requirement, for example, for public customers in the US. You always have to provide an SBOM if you deliver software, and this way you can also sign it and have a proof that nobody tampered with your SBOM and nobody tampered with your package. So, and that was the last slide, and now I have the image from before that you cannot see still. Yeah, I hope I could move a little bit the security part from being like the antiseptics to the anesthesia, right? To make it a little bit better, or to get an understanding. So how can we integrate this with a developer-first mindset, using virtual development environments, doing exercises for developers like awareness trainings or red team, blue team simulation, and providing the tooling for automating dependency management, code analysis, and secret scanning, so that this is all baked into the process. So thank you very much, and if you have questions, now would be the time. Slide is down there. Okay. Should we first do the room, or I don't know if we have a mic. There's one question. Event stream, the event stream incident. Okay, so the question is, would have GitHub detected it and would help against the incident? Yes, and it would, because the moment that flatmap stream had the vulnerability, it was reported to the GitHub advisory database, and Dependabot would have said to you, there's a dependency in there, right? So, and you would get the alert and you could fix it. So it would help you by just surfacing the dependency. Let me see. Do you see any other way to secure developer machines except CDE? How to deal with developer needs to be able to install various helper productivity tools? Yeah, I think that's the perfect thing for virtual environments. And this can be local, this can be in the cloud. I'm a big favor of the cloud, because normally internet connection is not an issue today. And I mean, problem is still if you're Windows based, then you need a Windows machine. But I tried DevBox lately, and it's really awesome. I was really impressed how fast it is. So this is really optimized for also running Visual Studio. So it's probably very much for .NET developers, and in your Java, it's like, yeah, I need Eclipse. I've not tried that. But the DevBox was really, really fast. And you can completely customize it. It's really like your own development environment. You can install all your tools. You have a config file, so you can share the config with your other developers. Yeah, I think that's the best way for me to be productive for developers and still be more secure. I think being local admin on a machine where you read your emails, where you do your teams and you open all your files, that's just not a good idea, and you need something to fix that. If you can work locally without admin rights, okay, but still installing all the tools on your local machine is also not a productive way, right? Having a container, having a virtual machine is just more productive in the long run. And hardware is not the bottleneck and network is not the bottleneck, right? So that should be always, you can containerize it locally, you can have a VM locally, but you should have some form of container that you use to develop. Does Dependabot deal with the Maven ecosystem and Gradle project? Yes, it does. Not as good as with other languages. So a lot of packages are supported, like STB, for example, for Scala and also for Java. It is supported, but not natively. So you need a build, and in the build, you have to run the tool and then upload the results. There's a native GitHub action, so it's really easy to implement it. But there's one step more you have to do compared to NPM, NuGet. I think Maven is supported fully, and I think Gradle, or one of the other, I'm not 100% sure. They're both supported, but you have to do something in a build that will update upload the results. Next question. How CodeQL compares to SonarCloud? Are they similar tools or different tools for different purposes? Well, there are different tools for different purposes, I would say. So SonarCloud is a really good tool. And especially, you can use both, right? SonarCloud uses Serif, so you can integrate the results also in advanced security. I think the findings from CodeQL are more accurate. You have less false positives, but you have less supported languages. So, for example, if you use COBOL, COBOL is only SonarCloud. We don't support COBOL in advanced security. I'm sorry. So that's, for example, the reason I have customers that use SonarCloud and advanced security. But I think the queries are more powerful in the CodeQL engine, but I'm maybe a little bit biased, so you have to compare it. But I think SonarCloud is more about code quality, and CodeQL is more about code security, I would say. And both can both. So CodeQL does also gives you quality checks, and SonarCloud gives also security. But I think one is more for security, another a little bit more technical depth. Are there any tools to detect application architecture level security issues? That's a difficult question. I think there are some tools, not in the GitHub ecosystem here. I would say CodeQL detects some of it. So as it knows the flow of the application, right? So it creates from your code a database, and not just the syntax tree, but also the data flow tree, how the data flows through your application. It can detect patterns that are bad, because it's normally related to that, right? You have the flow of data, and somewhere in there is something, but it's not specialized on that. And I'm not aware of really tools, because it depends how do you document. So if it's UML, what tool do you use? And I'm not aware of a good tool I would recommend here. I think architecture is still something that you probably have to do manually. That's my take. How good is Dependabot in terms of not suggesting updates to versions that contain malicious code? That's very good, and I have it actually in my demo. I didn't show you because there was a little bit, we were short on time. There's an action in GitHub Action that is called dependency review. You implement it, and it will check and give you an OpenSFF score, and it will fail your pull request if you add a new dependency to a vulnerable dependency. Yeah, it will directly fail. That was it online. Any more questions here? If not, I'm happy to take them in the Ask Me Anything corner if I find it. And yeah, thanks for being here, and enjoy the rest of the day.